This is part 2 of the semester final review for the first question. It's asking for the solutions. Now, if we look at the graph, we have an x-intercept here and an x-intercept here. Now it's asking for the multiplicities also. And if you notice at 3, there is a bounce, which means we have a multiplicity of 2. Over here, it goes straight through the x-axis, so this has a multiplicity of 1. Okay, we're going to look at the first term. We're going to divide them of each expression. So x cubed divided by x, that's x squared. We're going to put this on top. And then we're going to multiply it times the whole expression, which is x plus 2. We get x to the third plus 2x squared, and that's going to go directly in. So we're going to bring this one over, x cubed plus 2x squared. Change the sign. These cancel. This cancels also. Bring down the next term, which is x over x. And we do the process all over again. 0x squared divided by x is 0x. Multiply that by x plus 2. Multiplying it by this. And this is going to give us 0x squared plus 0. And then we get 4x, and then bring down that plus 2. So then we're going to do the process again with 4x. So we've got 4x divided by x. That's 4 multiplied by x plus 2. We get 4x squared. 4x plus 8. So 4x plus 8. Change the sign. Canceling, we get negative 6. Plus 6. Notice how the question is just asking us to find the remainder. So our remainder would be negative 6. Let's go ahead and do the next one. We're going to divide these two. 2x squared divided by 2x. We get x, and then we're going to multiply it by the whole thing. 2x 3, distribute 2x squared plus 3x. That's going to go directly under. And then we're going to change the sign. Cancel, this is a negative 20x. And then we bring down the next term. Now this one up here is going to be x. And then we're going to do the process all over again, except we're going to use negative 20x over 2x. This is negative 10x. And then we multiply it by 2x plus 3. Oops, it's just negative 10. And then we distribute negative 20x minus 30. And we're going to switch the sign. These cancel. We get negative 8. And then it's also asking us to just find the remainder. So our remainder would be negative 8. Okay, we're going to use synthetic division to find this remainder. 3, 2, this is 3, 2, 1, so we don't have any placeholders for this one either. Remember to solve for x. That's going to be the number in here. We've got x to the third and a constant. So we've got we're going to bring down the first term, and then we're going to multiply all of them by negative 3. This is negative 6, and then we're going to add them. That's negative 3, and then we multiply by negative 3. That's positive 9. Add them, we get positive 5, then multiply by negative 3. That's negative 15. add them, we get -7. So this is my remainder. And so it's also asking us to first number, that's 2, and then we're going to multiply all of them by -3. Gives us -6. We add them, we get -4. Multiply by -3, that's +12, that gives us 0. Multiply by -3, that's 0. Then we add, that gives us 1 times -3, that's -3. Then we add them and we get 6 minus 3 is 3. And again, we're looking for the remainder. The remainder would be +3 for x minus 1x for x is equal to -1. And then we're going to subtract 1. The next one, we need to isolate the number with the exponent that has x. Means we're going to add 6. So 4 to the x plus 1 is equal to 16. In order to solve for x, these bases need to be the same. So 4x plus 1, this 16 is 4 to the second power. So instead of 16, we're going to write 4 to the second power. Now that the bases are the same, then our exponents say x plus 1 is equal to 2. So x is equal to 1 when we solve for x. For the next one, material bought in urea, the equation describes the material's car value using that equation. What is the value after 3 years? That means x is equal to 3. So we simply write our equation and then we put it to the third power. Use your calculator. Okay, so we put it in our calculator and we get 17,310 cents. So it's asking what is the approximately when will the car be valued at 6,800? So this is the value when the car is worth 6,800. So we're going to substitute this y for that amount. So we're going to say 6,800 is equal to the equation to the power of x. And because my exponent is an x value, we're going to convert this into log form so we can solve for that x value. So to solve for x, we isolate the number that has that exponent. So that means we're going to divide both sides by 23,000. So use the calculator. We've got 6,800 divided by 23,000. And we're going to put it as a decimal. So 0.295. So we're going to round it to the nearest hundredth, which is 0.3. Get 0.30 if we round it to the nearest hundredth, and that is 0.91 to the x power. I'm going to rewrite it up here, where we have the exponent on the right side, and then I'm going to convert this to log form. This is my base. Say it is log of base 0.91 of 0.3 is equal to x. So we're going to plug this part into the calculator. We've got log base 0.91 of 0.3, and that gives us 12.76. So x is equal to 12.96, which is approximately 13 years. Okay, let's look at the next one. All right, for this next part, we have an exponential equation. So my parent function typically looks like this. So from here, we can say that our domain, regardless if it's moving up or down, left or right, it's going to be negative infinity to positive infinity. Now the asymptote to that equation, remember my asymptote starts at the x-axis, so at y is equal to 0. Now if you notice, this is shifting down 6 because my k is equal to negative 6. So that means my asymptote is also going to shift down 6 units. So the asymptote for this equation is y is equal to negative 6. Now it's asking true or false, is the graph exponential decay or exponential growth, or if it's an exponential decay. Remember, if your number is bigger than 1, then it's an exponential growth. If it's less than 1, then we have an exponential decay. Because 2 is my b value, then we have an exponential growth. So this is going to be false. Let's look at the next one. We want to expand this number, this log. So you want to separate the numbers first because each one is going to get a log. So we start with log base 2 of b. Because we're multiplying, that means we're going to add log base 2 of a plus log base 2 of e. Next one, we're going to separate these as well. 2 and the x to the third, and then the division, each one gets a log. We've got log base 2, base 4 of 2 plus log base 4 of x to the third. And because we're dividing, we're going to subtract log base 4 of 5. Notice how this one has an exponent, so that exponent is now going to be the coefficient. So our final answer is log base 4 of 2 plus 3 log base 4 of x minus log base 4 of 5. For the next one, we're going to rewrite this from log to exponential. We start with our base. Our base is x to the power of 6 is equal to b. This one is exponential to log 4. So we start with log, and then again, our base is going to be q, and then of x is equal to the exponent, which is 6. So we're going to condense this side because they're being subtracted. That means we can condense them with log base 15 over 5. And that's going to give us log base 3, or log base 10, 3 on the right side, and then log base 10, 3x plus 2. Because the logs are the same, their bases are the same, then we can say 3x plus 2 is equal to 3. And then we just solve for x. 3x is equal to 1, x is equal to 1/3. On to the next one, same thing. Here we're multiplying because the logs are being added. So we've got log base 4 of 2 times x is equal to log base 4 of 64. Because my log and bases are the same, then we can say that 2x is equal to 64 divided by 2, and we get